In this short video, we are going to look at how to solve a quadratic equation by completing the square. So let's talk about what completing the square actually means. The whole purpose of using the completing the square method, I'll just make a brief note here, is that let's just say we have a quadratic equation, so x squared plus 5x plus 4 is equal to 0, okay? The whole purpose of completing the square is to get this quadratic equation expressed in a way where we have x plus or minus a number, I'm just going to call that b, squared is equal to maybe some other number here, might be 5. So then what we can proceed to do is square root both sides and then get x by itself. So this is the factorization that we're actually looking for when we're doing the completing the square method. Now let's see how that works out. Let's go over here. So let's start off with the example I just gave. X squared plus 5x plus 4 is equal to 0. So to complete the square, there's a couple of things we need to do. First of all, we need to just get the equation so these are on the left-hand side. And to do that, what we do is just get rid of the 4. So then we'll have x squared plus 5x is equal to minus 4. Then from here, what we do is we have a look at this part here. And from here, what we'll proceed to do is kind of try and see if we can get this looking something like this. And to do that, there's a couple of things we need to do. We need to look at this middle term, okay? So our middle term is 5. What we're going to do is take the middle term, okay? Then we're going to halve the middle term, so halve it, and then we're going to square it. Square it. So then using the example of 5x, what we have is if we take half of 5, it's going to just be 5 on 2, and then if we square it, it's just going to be 5 on 2 squared. And with this, we're going to add this to both sides of our equation here and here. So let's do exactly that. So we'll have x squared plus 5x plus 5 on 2 all squared is equal to minus 4 plus 5 on 2 all squared. Remembering, we need to add things to both sides of the equation to keep it balanced. Now from here, what we can do is have a look at our left-hand side of the equation and actually factorize this as we would with a normal quadratic. And remember, to factorize it, okay, we look at this term here, the 5, and we think what two numbers add to give 5 and what two numbers multiply to give 5 on 2 squared. And the short answer to that is 5 on 2, because 5 on 2 plus 5 on 2 is equal to 10 on 2, which is 5. And then, of course, 5 on 2 times 5 on 2 is 5 on 2 squared. So basically, whatever number that you came up with when you halved that middle term, that's what you're going to put into your brackets when you factorize. Okay, so let's do exactly that. I'm going to go straight to putting that 5 on 2 in brackets. So I'll have x plus 5 on 2 close bracket. And then I'm going to put this in my second set of brackets. And that's going to be equal to negative 4 plus 5 on 2 squared. Okay, and when we enter this into a calculator, our answer is going to be 9 on 4. Now from here, we can just quickly write the left-hand side as x plus 5 on 2 all squared, and that's going to be equal to 9 on 4. So as you can see, we have what we were looking for earlier, okay? We have this part of the equation factorized as a perfect square. Okay, now let's continue. Let's finish this question off. First of all, let's just write it in here again. So we have x plus 5 on 2 all squared is equal to 9 on 4. So in terms of where we go to from here, we need to get rid of this squared. And the way we do that is by square rooting both sides. So when we do that, the square root will cancel off the squared. So we'll just end up with x plus 5 on 2 is equal to, and here we have square root 9 on 4. All we do is just take the square root of the top and the square root of the bottom. Of course, remembering to add plus and minus in there as well. And when we do that, our answer is going to be plus minus, square root of 9 is 3, and square root of 4 is 2. Now in terms of where we go to from here, let's go back up here again. We take one case with the positive and the other case with the negative. So let's take the case with the positive. If we had x plus 5 on 2 is equal to 3 on 2, so just positive 3 on 2, what we'd simply do here is move the 5 on 2 across to the other side by subtracting. And when we do that, we'll have x is equal to 3 on 2 minus 5 on 2. What we'll find is that that's going to be equal to negative 2 on 2. So x is going to be equal to negative 1. That's taking the positive case. Now let's take the negative case where we have x plus 5 on 2 is equal to minus 3 on 2. Same thing, we'll move the 5 on 2 across, so we'll have minus 3 on 2 minus 5 on 2. And then minus 3 minus 5 is negative 8. Divide that by 2. X is going to equal to negative 4. So we know our answers, therefore answers are going to be x is equal to minus 1 and x is equal to minus 4. And that's how we solve a quadratic equation by completing the square. Now there's one important thing to note, and that is that our equation that we are solving using the completing the square method, it must be monic, okay? Meaning the term in front of our x squared must be 1. So we shouldn't have a 2x or a 3x here. If that happens, we'll need to change some things with our equation. Now let's look at an example of solving quadratic equations by completing the square with a non-monic quadratic. So let's say this time we have 3x squared plus 2x minus 1 is equal to 0. So once again, we need to make sure that when we're using the completing the square method, our equation must be monic, okay? Now to make our equation monic, all we need to do is divide each of our terms in our equation by 3, and that'll make sure that x squared only has a 1 in front of it, because 3 divided by 3 is 1. So let's do that. So then we'll have x squared plus 2 on 3x minus 1 on 3 is equal to 0. And as soon as we've done that, we can then proceed to use our completing the square method. So let's start by moving the 1 on 3 across to the other side. When we do that, we'll get x squared plus 2 on 3x is equal to positive a third. That's just adding 1/3 to both sides. And then what we do is we do our same process that we did previously. We look at our middle term, we halve it, and then we square it. So our middle term is 2 on 3. We take half of it, we can multiply it by half, and then we square it. Our answer to this is going to be 2 times 1 is going to give us 2 on the top, and then 3 times 2 is 6 on the bottom, all squared. And just simplifying that down a little bit, we'll end up with 1 on 3 squared. We don't need to square it at all just yet. So let's take this and let's add it to both sides of our equation. So we'll have x squared plus 2 on 3x plus 1 on 3 all squared is equal to 1/3 plus 1 on 3 all squared. Then let's do our factorization. So factorizing this part here, once again, 2 numbers that add to give 2 on 3, same 2 numbers to multiply to give 1 on 3. The answer to that is 1/3 and 1/3, because a third plus a third gives us 2 on 3, and then a third times a third gives us a third squared. So let's put those in. So then we'll have x plus a third, and x plus another third is equal to 1/3 plus 1 on 3 squared. That combined together is going to give us 4 on 9. So let's just go up here and finish things up. So just making this more tidy, we'll have x plus 1 on 3 all squared is equal to 4 on 9. Then what we have to do from here is get rid of that squared. We do that by square rooting both sides. So then here we're going to have this square root cancel out the squared, so we'll have x plus 1 on 3. On the other side, we're going to have plus minus square root 4 on 9, which simplifies down to, because square root of 4 is going to give us 2, square root of 9 will give us 3. So we have 2/3 on this side of the equation. Okay, now let's finish things off. Taking the positive case, we have x plus 1 on 3 is equal to 2 on 3. Subtracting a third from both sides, we'll get x is equal to 1 on 3 as our final answer. Now taking our negative case, we have x plus 1 on 3 is equal to minus 2 on 3. We're going to subtract a third from both sides, and when we do that, we'll get x is equal to minus 3 on 3, which is going to simplify down to minus 1. Therefore, the answer to our quadratic equation, or answers I should say, x is equal to 1 on 3 and x is equal to minus 1. And that is how you solve a non-monic quadratic equation by completing the square.